Hi, Professor. This is my celebration of learning, and I did the video solutions. So let's get started. I chose three of the problems to do. The first one I chose was number one. This is the chess tournament days. It gives us four players. We have Nathan, Art, Mike, and Ben. And it lets us know in the problem that each of them play each other at least once out of the 3 days. So they did give us a clue, which is Nathan and Ben did play on the second day. And as I wrote underneath, I said, because we already know that Nathan and Ben played each other on day 2, we can put together that Mike and Art played each other on day 2. And because we now have day 2 figured out, it makes it just a little bit easier to do the other 2 days. And since none of them can repeat and none of the boys can play one of the other players more than once, we know that for day 1, Nathan can play Art, and then Mike can play Ben, which still leaves us good for day 2 with Nathan and Ben, and then Mike and Art. And then on day 3, which would give us the last, would be Nathan and Mike, and then Art and Ben. So all of the players play each other at least once, and they do get to play on the 3 separate days. This would leave us to our second problem. This is the candle problem, and as I listed on the very top of number 2, I listed the quantities. So we know that we know that we need to find the height of the original candle, as I said, is unknown. But we do know that at 2 hours the candle was 13.5 inches, and at 6 hours the candle was 10.5 inches. So underneath I drew a little diagram. I put the hours at the bottom, so I have 0, 1, 2, 3, 4, 5, 6 hours, and on the top, obviously we don't know the 0 hours, which would be the original height of the candle. And then for the 1 hour mark, we don't know that as well, but we do know that the 2 hours would be 13.5 inches. And then at the 6 hour mark, we know that it is the 10.5 inches. So what we were trying to find, I kind of listed here on the left-hand side, we're trying to find how many inches melted every hour. And we also need to find the original height. But in order to find the original height, we do need to find the amount of the declining height between each hour. So I kind of circled, I put a little question mark at the 1 hour mark, meaning, we need to know every hour how many inches it declined. So I first took, we needed to find out between those 4 hours, what's the amount inches it declined. So I did here on the right-hand side, 13.5 minus 10.5, which gave us 3. So I listed here in between the 2 hour and 6 hour, which gives you the 4 hours, which would be the 3 inches in decline. And so because we do know that, I took here right underneath, I put 3 divided by 4, and that's what gave us the 0.75. And I listed it here, that would be the every hour it melted 0.75 inches. So it was easy for me to do. I kind of made another diagram underneath, like the final product. Here's 0, 2, 4, and 6. I listed the 13.5, I listed the 10.5, and then as you see here, we are adding 0.75 inches every hour. So at the 1 hour mark, I added the 0.75, and we added another 0.75, which would give us 15 inches. And then on the right, I did list the original is 15 inches for the candle. Okay, and for the last problem, I chose to do the fraction example with Alana. So it says Alana is trying to explain why 3/7 is less than 5/9 to another student. More specifically, she says, so the top diagram shows 3/7 and the bottom diagram shows 5/9. They're both missing 4 pieces, right? But more of the 5/9 is shaded in the 3 than in the 3/7. So that's how we know that 3/7 is less than 5/9. So we're looking here, we're trying to figure out just a better explanation, not saying that she's wrong, but a better explanation so she's not confusing the other students as well. So what I did here is I wrote out exactly what she said. So I drew out her little diagram that she has, and this would be the 3/7, so 3 are shaded out of 7. And then I do have the 5/9, so 5 of them out of 9 are shaded. And I wrote here on the right and said both are missing 4 chips, but more of the 5/9 is shaded. And I wrote here down at the bottom, Alana is correct, but her explanation isn't as clear. By assuming both are missing 4 chips could be misleading, which confuses thinking that both are equal. The student can explain the fractions as pie pieces. So I wrote down at the bottom the 3/7. So what I would do is write down the fraction and explain the difference and the meaning between the numerator and the denominator. So if I have 3/7, I have the 7 as the total number of pies. And then I have the 3 as the total pies that can go into 7. So not so much that we're just shading in 3 and then have 4 left over, but more like there's 3 pies that can go into 7. So I shaded through, I circled 7 pies, and then I shaded in 3 in the red. And I put on the right-hand side, instead of thinking of how many left over in each fraction, think of it as pies. So then when she's telling another student, instead of saying, oh, she's missing 4 pieces, she can clearly say, well, how many pieces can go into the total number of pies per se. So then that would give her the 3/7. It's not that she's wrong, it's just a little bit misleading when she says they're both missing 4 chips. Because assuming that if they're both missing 4, okay, then they're both missing 4, and that makes them equal. So then they have the same remaining amount. So it's just a little bit confusing. So the teacher can simply explain it in a way with a diagram and with like total number of pies and how many times can they go into the total number of pies, which would be the 3. She's still correct, but as I said, it's just a little bit misleading when she says 4 chips. What does that mean by 4 chips? So then that's just how I explained it. And that is the end of my presentation. Thank you so much.